Right, good afternoon, class. Today we're going to talk about coterminal angles. Sort of something that Beckett kind of taught. Well, he asked about it, but we never really covered it in much detail other than they exist. We'll cover it in a little more detail today. Okay, so we'll go back to what we talked about yesterday in standard position. Again, here are two, I guess, more conditions for standard position. The vertex of the angle starts at the origin, and the initial arm of the angle is on the x-axis. As an example, this is what it means. There's our positive x-axis. Positive x-axis. The angle is measured from it. Now, one new term that I haven't introduced yet is this terminal side. And the terminal side is basically just the arm of the angle that you're measuring. Okay. Now, as we sort of covered yesterday, we can have this angle only represents one of a possible infinite number of angles. Actually, go around it once, that would be one angle. If I go around it twice, that'd be another angle. Go around it a third time, that'd be another angle. They all have the same terminal side. Okay? I could even go backwards the other way. That way is one angle, continue it, another angle, and so on. Okay. Sorry to look a little messy, but I hope you get the idea. So this terminal side represents effectively an infinite number of angles. And depending on the situation, we're going to be looking at one. Okay. So here's some more angles in standard position. Just some examples. Notice they're all being measured from the positive x-axis. The angle could be like that, or we could move away. Also around once and going there. Could be going around 3 times, 4 times, 5 times, 6 times, whatever. But it all ends here on the terminal side. This one here, this is my terminal side. And again, measuring from the positive x-axis, going all the way around there. Might even go once there. Okay. It could also be again measured in the opposite direction in case you get negative angle. Okay. Here, the terminal side, this one there. And the same thing, measuring from the positive x-axis all the way go around that. As I mentioned yesterday, it's technically not wrong to measure the angle from here. It's just this is not a standard. This angle is not a standard position angle. Standard position angle is going to be from positive x-axis around to your terminal arm. Okay. Alright, so what's a coterminal angle? But probably guess the idea. A coterminal angle is an angle with the same terminal arm. Angles with the same terminal arm. And if you don't restrict your angle range, or I guess angle domain, then you actually have an infinite number of coterminal angles. Okay, example of that. Okay, so here, sketchbook, draw a set of axes. So let's put a terminal arm. Okay, well, this angle could be this. That could be the angle. Or the angle could be around once. That could be the angle. That's perfectly fine too. Or it could even be once or twice. And that would be a perfectly acceptable angle. And this could continue on forever. We could keep going and going around and around and around the circle and eventually stop at this terminal arm. That'll be our angle. Okay. You also go the other way. You can also go negative, and that's one angle. This angle has the same terminal arm. If we continue going around, run around, I don't know. And there we go. There. So that angle goes 1, 2, 4, 5, or 4 times around, and then finally gets there. And those all have the same terminal angle. Or sorry, same terminal side. Because they have the same terminal side, they're all coterminal angles. Positive angles can also have negative coterminal angles. Because again, same terminal side, we're just measuring it differently. So the angle measured by the green line is the same, or it has a coterminal to the angle measured by the red line. So the green line angle is coterminal to the red line angle. If I were to draw a angle, let's say this, round like this, the angle traced out by the blue line is coterminal to the angle traced out by the red line, which is also coterminal to the angle traced out by the green line. As long as the angle or angles all have the same terminal line, they will be coterminal towards each other. That's what a coterminal angle is. Right, now to measure, well, let's go through some examples. So example, find coterminal angles for, let's do 40 degrees, first one. Let's, here, draw 40 degrees, something like this. Okay, so this is 40. Okay, so one possible coterminal this red be if I went around and once around like that. Well, it's going to be same 40 degrees, but I have added to it one full circle, which is 160 degrees. So 400 degrees is one possible angle. Another possible terminal angle, what if I go backwards? Backwards this way. Well, this is going to green, is going to be negative 90, negative 180, negative 270, and all the way to here. Be effectively negative 170 plus, add another negative 100 and okay. Or another way to look at it is probably not the best way to look at it is one full rotation negative is going to be negative 160 degrees, but we're going to add 40 to it because we're not going the full way around. We're part way around, 40 degrees is pushing it back a bit, and this. Okay, so it doesn't matter how you look at it, it should still give you the same answer. Now, if we were to go really crazy, it could go well around once, twice, and let's say 3 times. We'll stop there. If I go around 3 times, this will be 40 degrees plus 60 times 3, because we've gone around the circle 3 times. 360 times 3 is 72. 10. 1,100 and there you go. And all 3 of these are coterminal angle to one is negative, one just went around once, and one went around 3 times. But they're all coterminal angles. Okay, let's try another one. Alright, so negative 450 degrees. Find coterminal angle. Okay. Nope, apparently not. Let's see. Black. Negative 450. That's negative 360. 450. Oh, okay, negative 450. Line here. Negative. Alright, so one possible coterminal angles if I go this way. That's 170 degrees. That's one possible coterminal angle. Another possible coterminal angles if you this color way. Negative 90 degrees. There you go. So there's two possible coterminal angles. Negative 450. Negative 450. Negative 450. Again, two possible coterminal angles for negative 450 is 270 and negative 90. Both work fine. Right. Last example. Give you a radian angle. That's what we were working with yesterday. Find the coterminal angle for 5 pi over 4. Alright. This. Okay, so 5 pi over 4. Here is pi over 2 pi, pi of 5 pi over 4. Somewhere is pi over 2 pi, pi, probably something like this. This is 5 pi over 4. There we go. Okay, so find coterminal angles for this. Well, you can go around this way. Okay, this will be negative 3/4 pi. That's one possible angle. Another possible angle around once. There. This angle will be 5 pi over 4 plus, well, we went around it once. Going around the circle once is just 2 pi. Okay. And that's it. So the radian angles work very similarly. The only difference is that we are working with pi's. Before we move on, I should point this out. If I can way. Another one. Okay. So I'm going to draw a bunch of lines on. First, I'm going to draw here. This will be pi over 2. 0. Line here is pi. This line here is pi over 2. Okay, so just some quick references as to where the angles are or where the radius is. Okay. If I draw a line this way, exactly halfway between this line will represent pi over 4. Because this line is exactly halfway between 0 and pi over 2. You can do this on the other side. Pi over 4. Process. This not 3. This 5 pi over 4. 7 pi. Okay. Now that makes sense because if from here to here, so here to here, pi over 2, then if I'm going halfway, it'll be half of pi over 2, which is pi over 4. Then we just do that process. Further continue this on by doing this. This will be half of pi over 4, so pi over 8. Continue the process this way. Pi over 8, but 7 pi over 7 pi over 8. Now we can continue this process. This is just to sort of give you an idea of approximately where to place your pi angles. Alright, we'll deal with that a little bit more later. Okay, now, as I mentioned earlier, because coterminal angles, unless you restrict the range of the angle, then can't possibly write all the possible coterminal angles, because there's just an infinite number of them. So, rather than writing each individual coterminal angle, we use an equation. And the equation is as follows. Pi plus 360, if it's in degrees, so degrees. One here is rad. Okay, so in degrees, all coterminal angles are going to be theta plus 360 degrees times n. And n is any integer, positive integer or negative integer, as long as it represents all the circles that you've traveled to get to your terminal angle. Radian is a similar thing. The only difference is that rather than we use 360 degrees, we use 2 pi times n. Pi times n is, again, 2 pi is just how, 2 pi is the angle covered by one full circle. So pi times n is n circles, which is what we did earlier. That's how we write the coterminal angle. Go back to, not this one, lost it. But let's say I wanted to find all the coterminal angles of this. Well, I can't possibly list them all, so I can write an equation. All the coterminal angles of pi over 8 are pi over 8 plus pi times n. That's it. This is all the possible coterminal angles. All possible. All possible. All I did was add a 2 pi times n. That's it. That's all you need. If I had a degrees angle, okay, I'll just plop one. X. If I had an angle here, angle was 240 degrees, then all possible coterminal angles will just be 140 degrees plus n. That's it, we're done. Again, n can be any integer. because if n is a negative integer, then just move it this way, backwards. That's it. All we need. Okay. Hopefully that worked out well. You guys can just watch this video again and again and again, and you can probably find other videos online to help you out if you need to. Meanwhile, here is your assignment.